Hello, everyone, and welcome to Building a macOS Screensaver with Kotlin. Thanks for choosing the weirdest talk in the time slot. My name is Martin Brown. I'm a developer advocate at JetBrains. And the story I have to tell today is long and convoluted, and I'll only really be able to cover the first chapter of it today. But do stick around until the end, because I'll give you a sneak peek of what comes after that. But because we are going to be short on time, let's get started. That was not supposed to happen. Our story starts here at KotlinConf 2 years ago, where we were back to Copenhagen, as you can see here, and the keynote and Hadi and all of this was super interesting and exciting. But what I was really fascinated by was this, the idle animation between the sessions on the big screen, which was the logos of Kotlin over the history of Kotlin logos, starting from the teapot all the way to latest and then Cody, just bouncing around the screen in the style of all the DVD screensavers. And as it happens, a bit later, I joined JetBrains, and I found the designer who made this. And I was sad to find out that this was not a real screensaver that you could just use. It was a pre-rendered video for the specific keynote screen, a big LED wall. So of course, what do you do when something that you really want to use doesn't exist? You create it yourself. And I wouldn't call myself an Apple developer in any way, but I did find that there is a framework for this, which is called the Screensaver Framework. And this sounds great initially, and then you start reading the details, which include fun things like you can write screensavers with Objective-C, which is the very last thing that I want to do. And then there's just weird things, like you can use the available function to produce random values and centering rectangles. And so screensavers are really just native macOS apps, so I really don't know why these are the most critical features of a screensaver, but apparently you have functions for them. Creating a screensaver is pretty easy. You can go to Xcode, you start a new macOS application, and if you go to the very bottom of the other category, which is a strong signal of how important this use case is, you find the screensaver template. And once you create it, you will indeed be looking at Objective-C code. But if we take a look at here on the left, you'll see that what you essentially need to do is implement a screensaver view. And the first thing I wanted to do as a sanity check is to see if I could at least move this over into Swift. And I found a lot of posts telling me that I couldn't, that's just not supported. But luckily, like with any resource you'll find about building macOS screensavers, this was like half a decade old or more. So actually, since then, things have changed, something with Swift binary compatibility, and now you can use Swift. So here's a first Swift implementation of a screensaver, just showing you like what the interface looks like. Again, you're subclassing screensaver view. Then you have an initializer with very sensible things in there. You get the frame that you're going to render in, so you know the size that you're working with. It tells you whether you're running a preview, because you're either running inside a little window in system preferences or full screen for real. And you can also do things here like set the frame rate. Then the API is like, we had one initializer, yes, but what about second initializer? And this one is even marked with a keyword, with required, but it's actually never called. So you can put anything in there, you can fill with an error, you just have to make sure that you have it. Then you have an animate one frame function, which is fairly self-explanatory. This is what's called, in this case, 60 times a second, where you can update your state, put new things on the screen. And you have a couple things for showing a configuration sheet, which is like a settings dialog within system settings, where you can add UI to configure the details of your screensaver. But of course, what I really want is for all of this to live in Kotlin code. So I spun up a Kotlin multi-platform project. I made it target macOS on ARM and x86. And I exported it into a XC framework. If you've looked at KMP for iOS before, this will sound very familiar so far. We're just doing macOS instead of iOS here. And integrating it into an Xcode project is also the exact same as the iOS use case. So you add a new build tab, and you call into a Gradle build there, and that creates the framework and pulls it into Xcode. And now you can reference your Kotlin stuff from Swift. So this is the setup that I ended up with. I still do have the Xcode project, because that's required. And the entry point actually still lives in Swift code, because I found no way to move that over to Kotlin, the very first class that you launch into. But after that, it delegates everything just directly into the Kotlin implementation. So there's like 20 lines of Swift code here, and then there's hundreds of lines of Kotlin code that actually implement the screensaver. So we want the logo on the screen. We have to somehow put images into our screensaver. And for this, we can use the asset system in Xcode. We can throw in a bunch of PNGs, and as I later learned, SVGs also just work by default. So you can throw these in here, you can give them a name, and after that, you can load these from your code. And normally from Swift, you would do this by grabbing a bundle first. It has this special magic syntax, which I still don't fully understand, which goes like bundle for type of self. So you're kind of getting the bundle associated with your current class. And this is pretty hard to translate into Kotlin as is. But the NSBundle API itself, as with all platform APIs, is available if you're writing Kotlin code targeting macOS. So you can just import NSBundle, and there's a different function that's much easier to parameterize, where you just pass in your bundle identifier, and it gives you the same valid bundle, which will contain all of your images. From here, in Swift, you would load this by calling the image function for resource, and then passing in an unfortunately stringly typed name for the resource. And you can actually do the same thing in Kotlin. This is exposed for Kotlin code with an image for resource function. So you're just calling the same native platform API, passing in a string, and it gives you your image. So we loaded the image into memory. We have to put it on the screen somehow. For this, we can use AppKit, which is macOS's native solution for UI development, very similar to UIKit on iOS, very, very similar APIs across the board. And you can essentially just create new views. You can, for example, import an SImage in your Kotlin code. You can instantiate it by calling its constructor. You can use all the Kotlin things that you have. So, for example, you can apply configuration to it. And once you have that, you just add it as a subview of the screensaver view that you start with. The configuration, first of all, we want to put the image that we loaded on the previous slide in there. And then we need to set the frame that will tell us where the image should be displayed, or rather the image view. And here you can just freely place it on the screen. So you can put in coordinates, sizing, and it will appear at that point. And moving it around the screen is actually quite easy. As we want to animate it, you just create a new rectangle, new coordinates, you set it in the image view, and it moves to the new spot. So with these basic API calls, we add a couple of for loops and do some bounce checking so that we detect when we hit the edge of the screen and things like that, and we have our first implementation. And once we build the project, we'll get a .saver file as an output, which we just have to open, and that will automatically install our screensaver. We do have to confirm like 2 to 4 times, depending on how macOS is feeling, that we indeed want to open the screensaver that we just opened. But after that, we'll have the screensaver available. So this will install the screensaver or replace the existing version that you already had. And this replacing an existing version part is very critical, because as you're developing and you're making changes and you're trying to fix things, you really want to make sure that once you built it and installed it again, you're seeing your latest changes when you open your screensaver. And that's very much not the case by default if you're doing this. When I was struggling with this, I had a 7-step process for making sure that I've invalidated everything and that I will see my latest changes, which we're not going to go through today. I just want to highlight one of these many steps, which was that occasionally you just need to go to Activate to Monitor, you search for legacy screensaver. Legacy here is very much foreshadowing. And you need to force quit all of these processes before continuing. Again, just one of 7 steps here. But with that, we can finally have a working screensaver. It loads an image, it bounces off the side of the screen, and we're quite happy. At this point, we can add more features because we have the minimum implementation. And for example, I wanted to have another logo set. So by default, it was Kotlin's logos as they changed over time. But I also wanted a bunch of codies to put on my screen. So I wanted configurable logo sets. And it also makes sense to configure the number of logos on the screen. Again, like having 2 logos, it's just 2 for loops instead of 1 or something like that on the code level. So it's super easy to do. Or configure the size or the speed of the logos. Here, the interesting part for this settings implementation is not the UI as much, because the UI is very similar to putting views on the screen elsewhere, but it was the storage. For this, I just reached for user defaults, which is what I've known from iOS previously. This is a simple key value store, and it actually has the exact same API when you're using it on macOS, super easy to use. And again, you can combine the platform API that you have access to and you can import with all the Kotlin features that you want to use. So here, I wrap this into a delegate, for example, so that I don't have to call the API directly. But instead, I could have a preferences object like this, where reading or writing any of these properties would actually talk to user defaults in the background and store any of the configuration that I've set up persistently across restarts. You can also listen to these things. Again, the point here is really just that you have platform API access. You can sign up for notifications. And whenever the settings change, you can do things like reinitialize your screensaver so that you're running with the latest settings. After I implemented this, I found that there's also a separate dedicated class for storing things for screensavers called screensaver defaults. So I did the work of moving from NSUser defaults to screensaver defaults, because apparently it's what you're supposed to do. And I quickly found out that this class just doesn't work. It doesn't store things for you. You restart your app, you don't have your values anymore. It doesn't notify you of changes. I don't know why it exists. It's a screensaver API on macOS. This is how they generally work. But with this implementation, I could now have a lot of codies on my screen configured into small size, large numbers, and the different image set. A final feature I wanted to add was customizing the images, because it's nice that we have 2 built-in image sets that you can pick from, but it would be even nicer if you could add your own images without having to compile the project for yourself and rewrite some of its code. So I wanted a feature where we can just browse for a folder, and the screensaver would look at the folder, grab all the images, and load those. Here, again, macOS APIs are actually working really nice here, because these are not the screensaver APIs. These are just general OS APIs for like a browse panel and things like that. Again, we can combine it with all the Kotlin features using apply, passing in lambdas as the listeners, and so on. And once we browse for a folder, we can also enumerate all of the entries, all of the files that are in the folder. Again, all the constants, everything is available for you for free from Kotlin code. And it's actually worth highlighting here that name parameters also work. So from Kotlin to Java interrupt, you can't use named parameters, right? But when you're calling into one of these native APIs, you actually get to use them. And because you're going to be passing in a lot of null values and things like that, they actually help a lot in readability. So with this browsing feature, I now had basically the screensaver that I wanted to have. I had my folder with my custom icons set up. It would load them, and I could have them bouncing around my screen. And then Apple released macOS Sonoma just as I was about done with my screensaver, and they changed a bunch of different things. First of all, they released their own very fancy city flyover screensavers, which is bad news for a custom screensaver creator, because everyone's going to use these instead of downloading custom ones. And they also made some fun changes for your custom screensavers. Namely, I suddenly saw my screensaver using 100% CPU and hundreds of megabytes of RAM. So then I go to investigate, like see what's happening. And let's say that you're sitting on your desktop coding something. You let it go to the screensaver. At this point, the OS spawns a process for you called legacy screensaver. This is called legacy because there is a new API that they're using internally for their fancy screensavers, but you don't get to use that. So anything that you do custom is a legacy screensaver by default. Anyway, you go to your screensaver, it spawns the process for you, it loads your screensaver view, and it displays your content. And then you dismiss your screensaver, and you might expect some of this to go away, but it doesn't. The process actually sticks around, and the entire day as you continue to code, it is consuming resources, it's animating the logos, you just can't see it because it's hidden from you. But it gets worse, because the next time you let this go to the screensaver, it uses the same process, but it spawns a new view, which means that every time that you go to your desktop and then back to your screensaver over the course of a day, or as long as you reboot your machine, I suppose, it will keep spawning new screensaver instances for you. And these will eventually eat all of your resources if you don't somehow free them. And at this point, I was like, is it me? Is it my terrible code? Is it that I have this weird Kotlin setup instead of pure Objective-C? What's the issue here? And the internet was like, no, it's not you. We also have screensavers that are consuming 12 gigs of RAM regularly. And apparently this was a thing from the very early betas of macOS Sonoma, and they just never bothered to fix it. So you go looking for a workaround. I looked at a couple of things. There's a stop animation function, which seems like it would be exactly the callback where you can free some resources, stop your loops, and stop consuming things from your screensaver. This one's never called. So then I kept looking, and I found this post, which I can't emphasize enough is from 2009. Anyone in the room who was born after this? OK. So this post, which suggests that there are a couple different messages that you can sign up for, and there's 2 of these which are promising, which is will stop and did stop. And you can toss a coin here, because one of these is never actually invoked. But the other is. So will stop is something that you can actually use. It will signal to you when the screensaver is dismissed by the user. And initially, I was just removing myself, like my screensaver view from the process. So you would still have the legacy screensaver view process running the entire day, but it wouldn't have a view that's ticking away inside it. But then I realized that I can also just terminate the entire process when the screensaver is dismissed. And this works just fine. The next time that you need a screensaver to display, the OS will create the new process for you, spawn your screensaver view, and everything. In fact, quitting the process is what macOS did all the way until Sonoma, when they just stopped doing it. In summary, I would not recommend that you build your own macOS screensaver. It's a hostile environment. The APIs don't work. There's no debugging. You can do print line logging, kind of, but there's no crash details. You can't attach a debugger. It's really difficult. But if you ever need to touch a Kotlin native API, whether on iOS or macOS, don't be afraid of doing that. The APIs that work, if you're not using a screensaver API, so like any other API, works the exact same way as if you were using it from Swift, for example, and the interop there is really nice. You get all of this functionality for free, and you can use all your Kotlin things with it. And of course, I do want you to put some Kotlin logos on your machine, so I'm going to give you a link here in a moment to download this screensaver. But I know what you're thinking. Marton, you're giving a talk about Compose Hot Reload in the same room tomorrow, just after noon. Why isn't this screensaver written in Compose? What are you doing with apt-get? Well, that's the part of the story that we didn't have time for today. But if you go to the link that I'm about to give you, you'll see that there's actually a new setting in there in the menu where you can choose between renderers. So you can run the screensaver on apt-get, as you've seen here, or running on Compose. And there's also a demo mode, which you can see demonstrated here, which shows you which renderer it's using, and it's switching back and forth every couple seconds. So it's actually possible to use Compose to build a screensaver. And if you, again, follow the links and take a look at the template, you will find basically a prepared project for you when you just have a compose function that you can put anything into, including material components if you want to, and you can put that into a screensaver. One more reminder here, there's going to be office hours for both KMP and for all things Kotlin today and tomorrow afternoon, so make sure that you come to those and have a chat with us on those topics. And that's everything I wanted to cover today. Thanks so much for attending. Grab the screensaver and resources and everything from the QR code here, and see you around. Oh, I'm here for questions if anyone has them, including later at the conference at any point.
Thanks for the talk. Have you looked at other platforms like Linux or Windows?
I haven't, but now that I have a working, so obviously the apt-get implementation is macOS only, but now that I have a Compose implementation as well, which we didn't look at how that works, but it does work and it runs on native macOS, that is Compose multi-platform, which means you can also run it on JVM, for example. In the project, you'll actually find a JVM main application so that you can open it as just a window and run it on the JVM instead of having to like build the screensaver with the Xcode project, install it, and try to reinstall it and replace. So you can run it on JVM as well. And I'm not sure what the state of other native Compose platforms is. For macOS, it works. It's entirely unsupported, but it does work. If you can make the same thing work for Windows, I think you could do it quite easily there, because I think those are just regular executables. It needs packaging, but the code is there, it's in Compose, and it's only a matter of whether you can run it natively, or whether you can run a screensaver with the JVM on any other platform. I'm very happy to discuss this if anyone has experience. I didn't have experience with this one either. I just learned it along the way, but if someone has touched screensavers before, I would love to chat. In theory, it is multi-platform. You could run this on WASM if you want. I can deploy this as a website. That would be a fun thing to do.
Thanks a lot for the talk. Did you try making it an Android live wallpaper?
It would be really easy, I suppose. I'm adding that to my to-do list. Android live wallpaper. All right. I feel like that's probably everything. See you around. Find me with questions at any point. Thanks again.